Chapter 4, Loops, Part 5. So to input any numeric value, when valid values can be positive or negative, we can't use -1 or any other number as a sentinel value because it could potentially be part of our data set. So one solution is to use a non-numeric sentinel, such as enter a value or Q to quit. Next double won't be able to accommodate a Q to quit, so we have to use a special method called has next double. So it kind of keeps that next double in the buffer, and if we see that what the user has typed in is a double, then we can go ahead and read it by value equals in.next double. So notice the control on this while loop is while in dot has next double. That means that the user has typed in a double value. The has next double returns a true for it's okay, we can go ahead and read that double, or a false, meaning they must have entered Q to quit. Some common loop algorithms, things that we do a lot. Number 1 are summing and averaging a value. Number 2 are counting matches. Number 3, finding a first match. That means looking for something in a list. Number 4, prompting until a match is found. So, oh, you didn't get it you didn't guess the right number. Guess again. Number 5, finding the maximum and minimum values in a list. Maximum or minimum values in a list also. And then number 6, comparing adjacent values. So here's a sum and average example. We can sum values initializing a total to 0 using a while loop with a sentinel. So double total equals 0, while in dot has next double input equals in dot next double, total equals total plus input. So we are accumulating using the variable total. To average a set of values, we use that sum algorithm, plus we count how many values are there. Int count equals 0, count plus plus inside the loop, and then outside the loop, if count is greater than 0, then we can go ahead and calculate the average by dividing total by count. Be careful to have that if statement, because if count doesn't equal 0, then we could potentially have a divide by 0 error, and our program would crash. Counting matches is another common algorithm. Let's say, for example, we want to count the number of times something occurs in a list. We would initialize our counter to 0. We would use a for loop to make sure that we looped through each element in the list, and then we would add to our count per match. In this case, we want to count how many uppercase letters there are. So int uppercase letters equals 0, that's our counter. For int I equals 0, I less than str.length. Recall that the length method tells us how many characters are in a string. So we have to loop while I is less than str.length, because when I is equal to str.length, we've gone one too far. I++, char ch equals str.char at I, so we're getting each character in the string. If character dot is uppercase ch, so if that character they typed in is an uppercase letter, then we increment our uppercase letters counter. Finding the first match. We want to initialize a Boolean sentinel value to false, meaning we haven't found it. We need to initialize a position counter to 0. That's going to be the first character in the string. And then we use a compound condition to control the loop. So, so we have while not found, that's our Boolean variable, and position less than str.length. So if position equals str.length, we stop because we've gone through all the characters in the string. Ch equals str.char at position, so we're using that temporary variable ch to hold the current character. If character dot is lowercase ch, so we found a lowercase letter, then we set found equal to true, assuming, of course, we're looking for a lowercase letter. We might be looking for x, in which case we'd see if it was equal to x, or you might be looking for hyphen or some other kind of character. We set found equal to true, else we increment position. That means that we're going to go look at the next character on the list. If we've set found equal to true, then when we go back up to the top and test our loop control condition, not found will be false, so our loop will end. We can also prompt until a match is found. We initialize a Boolean flag to false. We test a sentinel value in our while loop. We get input and compare it to a range. If the input is in the range, we can change the flag to true. If the input, and if we change the flag to true, the loop will stop executing. Else, we're going to display a message to the user saying they have invalid input. So Boolean valid equals false. Double input. While not valid, so we haven't received valid input yet. System.out.print, please enter a positive value less than 100. We get something from the user, and we say if 0 is less than input and input is less than 100. So we're getting a positive value, something greater than 0 and less than 100. If that's true, we set valid equal to true. Else, we tell the user invalid input, because it's annoying for the user to keep displaying the same prompt. Please enter a positive value less than 100. Please enter a positive value less than 100. They won't know what they've done wrong. So if you say invalid input, they're like, oh, that's why it keeps prompting me. And hopefully that will give them a clue to enter a value that's in the right range. Finding the minimum and the maximum. The first thing we do is we set our largest or our smallest, because it's going to be the same algorithm. We're just going to flip that greater than sign to a less than sign. So we set our variable where we're holding the largest value equal to the first thing in our list, because it is the largest that we've seen so far. Then we loop as long as the user's got more input, so as long as in.hasNextDouble. We get input from the user, and we compare that input with our largest. If the input we've received is greater than our largest, we set largest equal to that input. And we keep going until the user is out of values to input. By the time we're done with this loop, our variable largest will contain the largest value the user entered. The same could be true with the smallest. The only thing that we would do is we would change the name of the variable from largest to smallest, and in our if statement, we would change that greater than sign to a less than sign. It's the same algorithm otherwise. Comparing adjacent values. If we're comparing adjacent values, we get the first input value, and then we compare it to the next input value, and so on, comparing just those two that are right next to each other. We use the while loop to determine if there are more to check, and we copy the input. We have to make sure that we move the current input into our previous so that we can keep advancing as we get more input. So double input equals in.nextDouble, while in.hasNextDouble, so as long as there's more input, we get that input from the user and we store it in a variable called previous. Then we set, excuse me, I said that wrong. We have our input that we already got from the user that we store in previous, and then on the next line we get nextDouble. Notice there's a typo. I'm so sorry, I just noticed this. The line that says input equals nextDouble, that should say input equals in.nextDouble. So in.nextDouble, we'll get the nextDouble from the user. We will compare it with the previous value, and if they are the same, we say duplicate input. Otherwise, we loop back up. Is there more input? If there is, we enter the loop. We put input in the variable previous, and then input we set to in.nextDouble, so we get that next input, and we compare input with previous. Steps to writing a loop. So we've gone through all these common loop algorithms, but how did the people who wrote them get there? When you're writing a loop, it's important, essential to have planning. Decide what work you want to do inside the loop. What does this loop need to accomplish? You need to specify what's the loop control condition going to be. What type of a loop is best? Do I need a while loop, a do loop, a for loop? So you need to set up variables before the first loop. So what variables are required to be set up before the first loop? What do you need to have a scope larger than the loop itself? You need to process results when the loop is finished. What are you going to do when the loop is done? And then it's important to hand trace the loop with some typical examples, like use some test data to see how that loop will behave. And all those 6 steps are before you write a lick of code. So make sure you plan first, because people who plan first have a much better time when it comes to coding the loop in Java. Implement is a $5 word that means coding. So make sure you have a plan either with flowcharts or with pseudocode before you start writing the loop.